Hey guys, so today we're going to be going through how we graph direct proportion as part of rates and ratios. If you're not familiar with how we work with direct proportion or how we look with graphs or use equations, please go watch those Call Me Pythagoras videos first before we get to this point. The aim of this video is so that you're able to draw and interpret direct proportion graphs. So you can draw them and you can also read from them. So what do direct proportion graphs look like and how do we interpret them? Well, let's first get into what they are and how they work. So we can graph direct proportion relationships in the form of y equals k to the x, where we know k is the constant and x and y are the variables. When we graph two quantities that are in direct proportion, we will see a straight line, and they form the y equals mx form. And the b will always be 0, and you'll see this when you do a bit of practice. We know that from y equals mx plus b, that m is the gradient. But when we deal with direct proportion, m is also the variable of the constant. So whatever the constant is, that's what m is. And that's what the gradient is. So the k that we see there in y equals kx will also be the gradient. So there are two things that we can do, or two main things we can do from direct proportion graphs. The first thing is we can find the gradient from a graph that's already given. And the second thing we can do is we can graph direct proportion. Also, there's lots of other things we can do. We can extrapolate information from the graph. We can interpolate information from the graph. There's lots of things that we can look at and look at the relationship between things such as currency and stuff like that. So let's look at the first set of steps. Steps for finding the gradient. Well, if you've looked at the gradient video, you'll know it's exactly the same. We can find the gradient from a direct proportional graph by finding a point on the line, any point, where the line crosses over on an exact corner. When you have your grid lines, you have exact corners, and you just look at where it crosses over on the exact corner. And we'll do a few examples of it. The next thing is, how can we graph direct proportion? Well, because direct proportion is a straight line, we know we can graph any straight line by finding two known pairs of variables, two known xy coordinates. If two pairs are not given, we can find the pairs by using the universal formula. The universal formula is something that you should know from the direct proportion video. Let's go put all of this in action. Let's have a look at this example here. Now this example here says that the currency rate says that 1 Australian dollar will give 1.5 New Zealand dollars. The New Zealand dollar is directly proportional to the Australian dollar. Well, it's given us a few things there, but part A says find the universal formula. Now, if you remember your steps from direct proportion, step 1 is to write your proportional statement. New Zealand dollar is directly proportionate to the Australian dollar, and we have the direct proportion symbol there, the fish symbol. Step 2, replace that fish symbol with equals k. N equals ka, so wherever the fish symbol was, put equals k. Step 3, sub in the variables from the values given in the question. So the values given in the question says that New Zealand dollars are 1.5 and Australian dollars are 1. So we have 1.5 equals k times 1. The next step is to get k by itself. We'll make k the subject. Now in order to get k by itself, I need to divide both sides by 1. And when I divide both sides by 1, k is by itself, 1.5 divided by 1 is 1.5. So now I write my universal formula. N and A being variables and 1.5 being my constant. And this is also the gradient, as we'll find out later. Now, the next part of the question says, using the universal formula, find two pairs of values, meaning two pairs of Australian dollar with its corroborating New Zealand dollar, or XY coordinate. In this case, X is my Australian dollar and Y is my New Zealand dollar. Now, I can put any A value in to find its matching N value. But I want to find values that will give me exact numbers that I can graph. So let's say, for example, we try when A is 10, when there's 10 Australian dollars, how many New Zealand dollars will that equal? Well, when we chuck it into the formula and we work it out, that's 15 New Zealand dollars. So 10 Australian dollars are equivalent to 15 New Zealand dollars. Now, when I look at my graph here, my graph goes up by tens. So although I could use a ruler and find the exact middle of 10 and 20 and go across down to 10, it's easier if I find values that give me whole numbers. So one of them is 20 and 30 and 40 and 60. Now, how did I get that? Well, I use my universal formula. Here, it's saying when we have 20 Australian dollars, how many New Zealand dollars are there? Well, I put 20 where the A is into my universal formula. 1.5 times 20 is 30. That gives me two numbers that go up by 10. That's perfect. Another one that works is 40. 40 and 60. 40 Australian dollars is worth 60 New Zealand dollars. So now I can plot those 2 points. So let's do the first one, 20 and 30. So 20 Australian dollars gives me 30 New Zealand. I put a dot there. Then 40 Australian dollars gives me 60 New Zealand dollars. So 40 gives me 60 and I put a dot there. Remember, when you're drawing any straight line graph, you only need 2 points and you can join the dots. And you'll see here, we then just join the dots and make a line. Now, in the question, it already gave us one set of values, which is 1 and 1.5. Now, if you get stuck and you can't find another value, all y equals kx forms of direct proportional graphs go through 0.00. So you'll see here, they always go through 0.00. So that can be another point you can use if you can't find a second. Remember, we're trying to find 2 points on the line where we can join them up. Now, the second part of this question says, what is the gradient of this linear graph? And hence, the constant of proportionality. Well, I already found the constant out up here when I was trying to do my universal formula where I found constant equals 1.5. And we already stated that that's a gradient as well. However, if you had not done that and you just had the graph or you just had some points, you can figure it out as well. We know that gradient is rise over run. Now the first dot point rises 30 and runs 20. 30 over 20 equals 3 over 2, which equals 1.5. Now the second dot rises 60 and runs 40. 60 over 40, or 6 over 4, or 3 over 2 equals 1.5 as well. So you notice the gradient is the same as the constant. Now we can find unknown values by looking at this graph. This graph's asking, how many New Zealand dollars will we get for 60 Australian dollars? So we go across to 60, and then we draw a line until we touch the direct proportional graph line. When we touch it, we go across, and that equals 90 New Zealand dollars. hopefully you're getting the hang of this. I have a few questions here that I'd like you to try. Pause the video, give them a shot, and then come back and look at the recommended answers. Well, there you have it. There's the recommended answers. Hopefully you got them all right. If not, go watch the video again. Till next time, take care, guys.